Welcome to the Deep Dive. Today, we're plunging into the immense power of destructive typhoons.
Yeah.
You shared an article with us, 10 most destructive typhoons from 10 most of today. And honestly, looking at these historical events, the scale of devastation is just, well, mind-boggling.
It really is.
Our goal in this deep dive is to really understand what made these 10 typhoons so incredibly impactful and kind of pull out the key insights for you.
That's right. And just as we get started, so you have a clear picture, let's quickly touch on the difference between hurricanes and typhoons. The source material actually does a good job of this.
Okay.
Both are tropical cyclones,
Yeah.
these powerful rotating storms that form over warm ocean waters. The name actually just depends on where they originate.
Oh, right.
So if these storms develop in the Northeast Pacific or the North Atlantic, they're called hurricanes. But the same type of storm that forms in the Northwest Pacific Ocean, that's a typhoon.
Okay, so it's purely a geographical distinction then. Now, here's something that really stood out to me in the article, and it's something for you to consider. It suggests that typhoons are often perceived as more destructive, simply because they tend to hit, heavily populated countries in Asia. It's a sobering thought, isn't it?
Yeah, absolutely.
The sheer density of people in the path of these storms can just dramatically amplify the human cost.
Precisely. It's not necessarily about typhoons inherently being stronger than hurricanes, although, regional climate patterns can certainly vary.
Right.
The crucial factor for you to understand is the vulnerability of the affected population. Higher population density means a greater potential for human casualties when these massive storms make landfall.
Okay, that makes sense. So with that in mind, let's get into the specifics, starting with Typhoon Nina in 1975.
Okay.
Now, this one is particularly striking for you to note because, according to the article, the primary devastation wasn't from the sheer force of the wind,
Right.
but from something perhaps even more terrifying, the collapse of the Bangkyo Dam in China,
Yeah.
a Category 4 typhoon leading to that kind of infrastructure failure. It's almost unimaginable.
Well, and what's fascinating here for you to consider is the cascading effect the source material highlights.
Yeah.
The initial breach of the Bangkyo Dam unleashed this enormous volume of water, right? And that surge then overwhelmed smaller dams downstream, causing them to fail as well.
Yeah.
It's like a domino effect of destruction, turning a severe weather event into an even greater catastrophe for the region.
And the death toll.
Hmm.
The article states approximately 229,000 people.
Unbelievable.
That makes it the fourth deadliest typhoon on record. It really underscores for you how the secondary impacts of a storm, like widespread flooding, can be far more devastating than the initial winds.
Absolutely.
It's a stark reminder that these natural events can often trigger, well, human-made disasters through infrastructure failure.
Yeah, exactly. It highlights for you the interconnectedness of our infrastructure and the potential for a single point of failure to lead to such widespread devastation. It definitely raises an important question about the engineering and maintenance of critical infrastructure in areas prone to these extreme weather events.
Definitely. Okay, next up we have the Haiphong Typhoon of 1881. Now, this one occurred way before many of the meteorological advancements we rely on today, so its category is unknown.
Right, much earlier.
But the sheer scale of the tragedy, the article lists it as the third deadliest typhoon ever recorded.
Third deadliest. Wow.
Hitting the Gulf of Tonkin and ravaging Haiphong in Vietnam and nearby coastal areas with an estimated 300,000 lives lost. That number is just staggering for you to contemplate.
It truly is. And without the sophisticated tracking and early warning systems we have now, populations were just far more vulnerable.
Yeah, you can only imagine. Yeah.
For you to understand the magnitude, consider an event of this scale hitting a densely populated region with, limited means of communication or escape. It would have been an unimaginable catastrophe.
Mm-hmm.
And it really speaks to the long history of these powerful storms impacting this part of the world.
Fast forward quite a bit to 2013, and we have Super Typhoon Haiyan. This one's probably more familiar to many of you listening.
Yeah, I remember this one clearly.
Hitting Southeast Asia, particularly the Philippines. The article calls it a Category 5 super typhoon and points out its record-breaking sustained wind speed at landfall, 195 miles per hour.
Just incredible force.
That's the strongest ever recorded globally when a storm actually made landfall.
The sheer force of those winds would have been unlike anything most people had ever experienced. For you to grasp the intensity, a Category 5 designation already means sustained winds of at least 157 miles per hour,
Right.
and Haiyan just blew past that threshold. The devastation across the Philippines was immense, and sadly, it was the deadliest typhoon ever recorded in the country, claiming around 6,300 lives. Ugh.
The scale of the destruction really underscores the vulnerability of even, relatively modern infrastructure to such extreme forces.
The human cost is just heartbreaking for you to consider. Okay, moving on, we have Typhoon Ida hitting Japan in 1958.
Okay, Ida 58.
Now, while the death toll of 12,269 is lower than the previous examples, the article really paints a vivid picture for you of widespread infrastructure damage. Over 2,000 buildings ruined,
Wow.
railway bridges washed away, roads destroyed. And then there was the significant agricultural impact, 2-foot-high tides wiping out over 120,000 rice fields.
Devastating for farmers.
Yeah, that kind of devastation would have had really long-lasting consequences for food security in the region.
And what's particularly striking about Ida for you is the multi-pronged nature of its impact. It wasn't solely the wind, it was the significant storm surge.
Right. The water.
That wall of seawater pushed inland by the storm's force and the resulting river flooding as the Arakawa, Kano, and Meguro rivers overflowed.
Oh, wow. Yeah, this flooding damaged everything from homes and stores to religious shrines and even freight depots. It really highlights how typhoons can cripple a region's ability to function on multiple levels.
Then there's Super Typhoon Sarah, hitting South Korea and Japan. The article doesn't give a specific date, interestingly. Another Category 5 storm with widespread rain and high winds, destroying thousands of homes, ruining crops, millions of dollars in damage, causing severe flooding, and leaving thousands homeless.
Another Cat 5. Intense.
What struck me here, and what's important for you to note, was the discrepancy in the reported casualties.
Oh.
Yeah, some sources citing 840 deaths, others claiming as high as 1,869. That huge variation really underscores the challenges in accurately accounting for lives lost in such chaotic and widespread disasters, right?
That's a crucial point for you to understand when looking at historical disaster records. In the immediate aftermath of a major event, establishing precise figures can be incredibly challenging.
Makes sense?
Communication disruptions, the sheer scale of the damage across a large area, and the displacement of significant portions of the population. It all adds up. The range in those numbers for Sarah really speaks to the immense force and far-reaching impact of the typhoon.
Okay, then Typhoon Vera in 1959. This was another incredibly destructive storm to hit Japan, and the article calls it the deadliest and strongest typhoon ever to make landfall there.
Deadliest and strongest for Japan. Wow.
A Category 5 superstorm. The numbers are just staggering for you to absorb. 1.5 million people left homeless.
1.5 million.
And 5,500 lives lost. Again, it was that combination of incredibly powerful winds, torrential rains, and enormous waves that caused such widespread ruin. Crops utterly destroyed, countless homes obliterated, and rivers overflowing their banks.
Vera really stands out in Japan's history as like a benchmark for the destructive potential of these storms.
Yeah.
For you to appreciate the scale, the combination of its extreme intensity coinciding with vulnerable coastal communities led to this immense human and economic toll. It actually prompted significant changes in disaster preparedness and infrastructure planning in Japan in the years that followed.
Ah, interesting. Okay, moving into the 1960s, we have Super Typhoon Nancy in 1961. Yet another Category 5 storm hitting both Japan and Guam.
Nancy 61. Cat 5 again.
This one has a unique distinction that's interesting for you to know. It apparently holds the record for the longest continuous period of maintaining Category 5 intensity in the Northern Hemisphere.
Longest at Cat 5, that's intense duration.
Yeah, slammed into land with winds clocked at 215 miles per hour. And while the reported death toll of 191 is lower than some of the others we've discussed, that sustained extreme intensity must have resulted in incredible structural damage across a wide area.
Absolutely. A storm maintaining Category 5 status for an extended duration, like Nancy did, means prolonged exposure to those extreme wind speeds and the associated torrential rainfall. So, even if the direct loss of life was lower compared to some other typhoons, for you to consider, the widespread and prolonged structural damage could have had significant long-term economic and social consequences for the affected regions.
Makes sense. Okay, jumping ahead quite a bit to 2010, we encounter Super Typhoon Megi, known as catfish, in Korea.
A Megi, right, the catfish.
This Category 5 storm made landfall in the Philippines and affected a truly massive area, impacting 23 provinces, 17 cities, and over 2 million people in total.
2 million people affected. That's huge.
The article mentions 69 deaths in Taiwan and the Philippines, but also highlights the very significant destruction to critical infrastructure, widespread damage to agriculture, and over 148,000 homes either damaged or completely destroyed.
Mm.
It really seems that even with more modern warning systems and evacuation protocols in place, the sheer geographic scale and intensity of these super typhoons make widespread devastation almost unavoidable sometimes.
Yeah, Meiji serves as a more recent example for you of the immense geographical reach that these powerful storms can have. Affecting millions of people across multiple distinct regions really underscores the ongoing need for robust international cooperation in disaster preparedness and the development of resilient infrastructure in all vulnerable areas.
Definitely. Now, Typhoon Wanda in 1962, which directly hit Hong Kong, is a particularly interesting case for you to consider
Okay, Wanda.
because it was classified as only a Category 2 typhoon at landfall. Yet the article identifies it as the most powerful tropical cyclone ever recorded to directly strike Hong Kong.
Only a Cat 2, but the most powerful for Hong Kong.
Interesting. It caused the ruin of over 2,000 boats and vessels, left a staggering 72,000 people without homes, and tragically resulted in 130 lives lost.
Wow, 72,000 homeless from a Cat 2.
This really highlights for you that even typhoons that aren't classified in the highest categories can still be incredibly destructive, especially when they directly impact densely populated coastal regions with significant maritime activity.
Wanda is such a powerful reminder for you that the Saffir-Simpson hurricane wind scale,
Huh.
while a useful tool, doesn't tell the complete story of a tropical cyclone's potential impact.
Good point.
Factors such as the extent of the storm surge, the total amount of rainfall delivered, the specific vulnerabilities of the affected built environment, and the local geography. They can all contribute to catastrophic consequences, even from storms that don't reach Category 5 status.
Right.
Hong Kong's unique geography and its deep reliance on maritime industries likely amplified the devastating effects of Wanda.
That makes a lot of sense. Okay, finally we come to Typhoon Forest in 1983, another Category 5 super typhoon.
Forest 83. Okay.
What's particularly notable about Forest for you is that it was recorded as one of the fastest-moving tropical cyclones in history.
Fast mover, huh?
Yeah. It caused significant damage in Japan, with over 46,000 homes damaged, yet the reported death toll at 21 lives lost was surprisingly low in comparison to the extent of the destruction. That might seem a bit counterintuitive to you.
That is an insightful observation for you to make. Lower death toll despite major damage. Yeah, why do you think that might be? Well, several factors could potentially explain that. It's possible that the rapid forward movement of the storm, while contributing to the extensive damage across a wider area, it maybe didn't linger intensely over any single highly populated zone for a prolonged period.
Yeah.
That could mitigate the potential for massive flooding or overwhelming storm surge in those specific areas.
Oh, okay.
Plus, advancements in building codes and more effective evacuation procedures implemented in Japan by that time may have also played a significant role in minimizing the loss of life despite the substantial damage to property.
Right. Better preparedness potentially paying off there. So as we look back at these 10 historically significant typhoons, some really critical themes emerge for you to take away.
Definitely.
The immense destructive potential of these natural phenomena comes not just from the sheer force of their winds, but from that dangerous combination, right? Torrential rainfall, devastating storm surge that inundates coastal areas, and the potential for cascading infrastructure failures, like we saw with the dam collapses during Typhoon Nina. It's just abundantly clear that human populations and our built infrastructure remain incredibly vulnerable to these powerful forces of nature.
Absolutely. And the varying degrees of destruction and tragic loss of life that we've seen across these different events really highlight for you the complex interplay of numerous factors.
Yeah.
These include the storm's inherent intensity, its specific track and speed as it makes landfall, the unique geographical characteristics of the regions it impacts, and crucially, the level of preparedness, the robustness of infrastructure, and the overall resilience of the communities that lie in its path.
Right. And the article we explored concludes with a rather sobering thought for you to consider, noting the ongoing limitations of our current technology to fully protect against these massive calamities, and emphasizing the vital and continuous importance of scientific research into these complex weather systems.
We still have a lot to learn.
It really makes you think deeply about the delicate balance, between human development and habitation in these often highly vulnerable coastal regions and the seemingly increasing intensity and frequency of severe natural disasters we are observing globally. What is the sustainable path forward when humanity faces such immense and at times seemingly unpredictable power?
That is indeed the fundamental question for you to ponder, isn't it? As our scientific understanding of these intricate weather systems continues to evolve, and as global climate patterns demonstrably shift, well, the critical challenge lies in identifying and implementing sustainable strategies.
Right.
Strategies that will allow communities in these vulnerable regions to not only coexist with these powerful forces, but to actively build long-term resilience and adaptive capacity. It's a huge undertaking.